residential mechanical inspections, and it again is based upon the 2018 edition of the International Residential Code. So you should have this handout. It's a workbook. It's a PDF downloaded. It's a really good PDF or workbook. Same as yesterday, the same makeup. We deal with modules and tasks. We'll go through things systematically. I have a real energy-packed class for you today. Like the plumbing, this stuff is kind of dry, but I got to tell you, I've got a lot of pictures in my PowerPoint. I've got a lot of graphs. I've got diagrams. I'm going to go through different systems with you to make you better than what you are, right? What does that mean? It sounds like the old show that I used to watch as a kid called The $6 Million Man, if you remember that at all, right? We can make you better, faster, stronger, right? We will do that today in our mechanical class. So given that, let's get started here. Hey, I don't think I need to introduce myself again. My name is Jerry Flanick. Again, I am your instructor here, and I know who you are because we introduced everybody yesterday. Okay, great. Let's move on. I need to get back into my code book to show you what we're actually going to do, where this information is. I mean, that's the key, isn't it? If you're an inspector, a plans examiner, a building official, you know what? You need to know where this stuff is at. The mechanical provisions of the residential code, they begin in chapter 12. They go all the way through chapter 23. And guess what? Chapter 24 is fuel gas systems, all right? So in essence, it spans from chapter 12 through chapter 24. It's huge. It's absolutely huge. Now, I'm going to make you a promise here today, and I'll keep going back to this. I'm going to sound like a broken record, okay? Because when people look into the residential code, primarily the mechanical provisions, there is a difference, ladies and gentlemen. You have to understand sometimes what the fuel source of the appliance is, because sometimes you may not be in chapters 12 through 23. If it's fuel gas like natural gas or propane, appliances and equipment, you are going to be in chapter 24, okay? This is the residential code. In the commercial code, we have two separate codes, the International Mechanical Code and the International Fuel Gas Code. I can't tell you, ladies and gentlemen, how many times I've seen mistakes made of building officials, of mechanical inspectors, building inspectors, architects, engineers. You quote the wrong codes when you should be quoting the fuel gas code, or you should be quoting a section out of the mechanical code. I'm going to leave you with that statement or those words of wisdom, and we're going to build this along the way. I'm going to show you and the fuel gas provisions of this particular code. Once you understand it in the residential code, it's pretty similar to the commercial code, except for bigger systems. And that's where we're going to be basing our knowledge on, okay? So let's get started here. First things first, I'm going to go to the table of contents like I did yesterday, and I'm going to show you exactly where the chapters are that we're going to be studying today. I'm going to go all the way to chapter 12 first. I'm going to make this a little bit bigger so we can see it. Chapter 12, it starts right here. And just like I do every class here, look at this. We have general administration requirements here for mechanical systems. We have 1202, ladies and gentlemen, that gives us mechanical existing system requirements. I guess I'll pose the question again. Do existing mechanical systems have the right to exist? The answer is yes, right? Provided they're maintained, provided they're in a safe working order. Can I add on to existing mechanical systems like ductwork, like hydronic piping, like gas piping. I can if I analyze it and it has enough capacity for the addition. Okay, I'm just going to click on this real quick here. Take a look at this. Very simple. If you have your code books, ladies and gentlemen, follow along. We have a whole section here for additions, alterations, and repairs. Make sense? Existing installations, they are allowed to lawfully exist as long as they're maintained and not overloaded, things of that nature, etc. And they have to be maintained. So given that, that's just the first part, right? We have Chapter 13, General Mechanical System Requirements. We will go through this. Now, there are some general requirements when we get into Chapter 24 for fuel gas appliances and equipment. But now we're just looking at Chapter 13. Chapter 13 gives me all different kinds of things like appliance access. I have to have enough room around the appliances for servicing. We'll talk about that. We'll talk about approvals, clearance from combustible construction. What we're looking at in Chapter 13 is primarily for solid fuel and oil burning appliances. Here's where Jerry sounds like a broken record all day long. Fuel, oil, and solid fuel burning appliances. Mechanical code, okay? Chapter 14, take a good look at this. You ready? Here it is. Heating and cooling equipment and appliances. Well, if we look at the heating and cooling equipment and appliances, if I run down this, Chapter 14, you see all these sections here? I see something for central furnaces. Make no mistake, ladies and gentlemen, this is for electric furnaces, oil furnaces, things of that nature, not fuel gas. Fuel gas you will find in Chapter 24. Those appliances are specific to the fuel. Duct heaters, electric duct heaters is what we're talking about. And then we've got some solid fuel stuff down here. Fireplace stoves and masonry heaters, things of that nature. So keep in mind, we always have to have a sense of what is the fuel source. Ask yourself all the time, what is the fuel source of the appliance? It will help and guide you through this code, whether you're in the mechanical part or the fuel gas part. All right, now, as we move on, exhaust systems, Chapter 15. I hope you're taking note of this because I'm going to save you a ton of time and a ton of pain over years of research and navigating through the code just by a couple simple little words called clothes dryer exhaust. You see this right here? Clothes dryer exhaust. I'm just going to click here real quick. Okay. I'm clicking and nothing's happening, but that's okay. Clothes dryer exhaust is given to us in Section 1502. Let me get rid of my highlighter here, then I can click on it. Right here. Clothes dryer exhaust. This type of clothes dryer exhaust, ladies and gentlemen, is primarily for electric clothes dryers. So, I mean, if I was you, I would be writing in my code book, electric clothes dryers right here. If you have natural gas, you're in Chapter 24. It's got a whole section on clothes dryer exhaust systems. Although it's the same information, if you're a building official, an inspector, a plans examiner, you need to quote the correct code section based upon the fuel source or the energy source of that appliance. Believe me, I've seen this before. I'm going to say it in a nice way. I've gone up against building officials out there that have done it wrong. And believe me, I look for the holes. I look for the holes that I can poke in your letters out there, right? You know, when people call me in to do some forensic stuff or maybe some legal stuff, believe me, I'll analyze it all day long. If I find a mistake, maybe you just made one mistake, right? You quoted the wrong code section. I say to myself, there's got to be other mistakes, right? Make sure you're right. Make sure you're right, because you know what? You sign your name to this stuff. You are the professional out there, all right? That's why I'm going through this pretty strict here today. I need you to understand. Chapter 16, pretty simple. Duct systems. We use sheet metal ducts, flexible ducts for air distribution. We also use the duct systems in Chapter 13 for certain exhaust systems that we pick or are required out of Chapter 15, like your bathroom fan exhaust, your kitchen exhaust, and maybe your ventilation systems, things of that nature. Here's a good one right here. Chapter 17 is combustion air. Combustion air. This is an easy one here because it just gives you 3 references. Let me show you. I'm going to make it real simple. Look at this. This is all there is for combustion air, ladies and gentlemen. But be careful. Again, Chapter 7 is only for oil-fired appliances. It gives you a reference standard. We'll go through this a little bit later. You're going to go to NFPA 31 for the combustion air for oil-fired appliances. For solid fuel-burning appliances, up here, guess what? You're going to use the manufacturer's installation instructions. And it's that simple. If you have fuel gas, what happens now? Gas-fired appliances like propane, natural gas, it's giving you a direction. You're going to get into Chapter 24. Chapter 24, specifically, it's G2407, gives you all the combustion air requirements, prescriptive and calculations for gas appliances. Okay, is that clear? All right, I hope it is. All right, now, that's easy, isn't it? Chapter 17 for combustion air, piece of cake in the mechanical code. Chapter 18, same thing. Chimneys and vents in Chapter 18 are for oil-fired and solid burning appliances. End of story. Okay, that's it. Fuel gas, you're into Chapter 24. Jerry sounds like a broken record on a Friday, doesn't he? Man, oh man. Stick with me. It gets better. Look at this. Special appliances is Chapter 19. Well, what makes them special? Absolutely nothing. They had to have a title for this chapter, so they called it Special Appliances. Ranges and ovens, big deal. They'll give you clearance to bottoms of cabinets and things of that nature. Sauna heaters. Sauna heaters. Electric heaters that are placed in a room. You have temperature constraints that you cannot exceed, maybe a timer, things of that nature. Things of that nature. Boilers and water heaters right here. Boilers and water heaters. All the safety controls for boilers and water heaters, you will go to Chapter 20 for both oil-fired boilers and natural gas boilers and also propane-type boilers. All the safety controls and everything is embedded in Chapter 20. That's where you get all the safety controls, the expansion tanks, things of that nature for all boilers, all fuel types as well, even electric boilers, okay? Chapter 21, hydronic piping. My gosh, there's a lot of chapters in this mechanical code, isn't there? People think mechanical stuff is real easy, right? Well, it is when you know how to navigate through this stuff, but look at all the different systems. This is called the hydronic piping chapter. I guess, let me ask you a question. What is a hydronic system? Do you know? What is a hydronic system?
Baseboard.
What is it, Don?
Baseboard.
Heating a fluid and circulating it.
Heating a fluid and circulating. Yeah, Don, I like that. That's good. What type of fluid are we going to heat?
Water, normally.
Primarily water, right. When we heat up water, we can have a hot water system, or contrary to that, we can have a steam system, right? But wait a minute, there's another thing here. Can I have chilled water as well? Absolutely. Chilled water, we don't see it a lot in residential, we see it in commercial, but chilled water piping. So hydro means water. Hydronic piping, water-based fluid systems are given here. We'll go over that a little bit later. Special piping and storage. This is for oil piping systems to supply oil to oil-fired appliances. It will go over the pipe materials, the size of supply, return piping, pumping requirements, tank venting, tank filling, everything's in here for oil supply systems for oil-fired appliances. Chapter 23 is solar thermal. This is where we circulate fluids through coils, if you will, that we mount up on roofs or outside of the building to capture the sun's radiant energy as a heat transfer mechanism to essentially get free heating of our water that's circulating through a coil. They're collectors. They're solar collectors is what they are. And we circulate fluid through coils embedded in these collectors. All right, here's where I want to be, chapter 24, right? Chapter 24. I don't know, if I were you, I'd get my big old highlighter out and say, you know what, chapter 24 may be pretty important because a lot of our customers out there have natural gas or propane, you know. This is a good chapter. So we've got a couple of general sections kind of looking at this. Take a look here. 2407, I've got a whole section on combustion air. And I've got some examples for you that we're going to work through today. And I'm going to show you how to calculate combustion air accordingly. We have two electrical sections. Look at this, 2410 and 2411. We have two electrical sections in the fuel gas chapter. This is for the prohibition. You can never ever use gas piping underground as what you call a grounding electrode. I'll go over that a little bit later. We also have a section on electrical bonding. This is where you will bond certain types of piping or tubing, like CSST. I will show you when and where you may have to bond corrugated stainless steel tubing. More stuff here. Pipe sizing. Gas pipe sizing for propane, gas pipe sizing for natural gas. I've got a nice day for us today. We're going to actually size piping or check the size of piping. I'll take you through some simple little calculations, and we'll be able to do it by the end of the day here today, okay? We'll talk about the approved materials, valves, flow controls in gas piping systems. It's not till you get down to this part here, right here, 2426 is called vents. Now you have to understand something. When we talk about fuel gas, we talk about the classification or the category of appliances, ladies and gentlemen. Don't use that slang that we hear all day long, like I've got an 80% furnace or I've got a 90+ furnace. Guess what? That language is nowhere in any of these codes. 90% furnace, 90+ furnace, 90+ boiler, that doesn't exist. We know what the percentage of efficiency is. The appliances are categorized in terms of category 1, category 2, category 3, and category 4. I will go over that with you. What I'm going to do is finish up with venting of the appliances at the end of the day. It's going to be our last exercise. And you will properly understand how to use this code to prescriptively size connectors and vents for category 1 appliances, okay? All right, we can find those categories of appliances in definitions. Now, I don't know how many code classes you've taken, especially ICC classes, but as instructors, we kind of tout chapter 2 as being definitions, don't we? Right? You're aware of that, aren't you? Let me bring in the class here. You're aware of that, aren't you? Chapter 2 is for definitions.
Yes.
Right? Right. Well, be careful, because there's another place that you find definitions. Take a look right here. 2403 is general definitions. All right. Let me open this up for you here. Boy, if I had my code book, I'd be highlighting this too. If you have fuel gas appliances or equipment related to fuel gas, you are going to look to 2403 for these specific definitions, okay? Because they're all gas right here, right? Simple kind of things, right? I'm talking about maybe just the term appliance right here. You see that word right there, the appliance? When we look at The mechanical code, when we look at the fuel gas code, appliance seems to mean the same thing, okay? And it is an apparatus or device that utilizes a fuel or raw material as a fuel to produce what? Light, heat, power, refrigeration, or air conditioning. Pretty impressive, huh? Well, if it's not an appliance, guess what it's called if it's not an appliance? Like, what's the piping called? What's the hangers called? What's the pipe fittings called? It's not an appliance because it doesn't utilize an energy form, right? Or a raw fuel.
Fixture?
What is it called?
Is it a
Apparatus.
fixture?
If it's not an appliance, it's called equipment.
Oh,
Go down to here and highlight equipment right here. Right? Look at the definition of that. Boy, oh boy, huh? It's like a circular loop, isn't it? Equipment is properly defined as apparatus and devices other than appliances. That doesn't really help us out, but it really does when you know the definition of an appliance. Equipment is everything else, pipe hangers, ducts, screws, everything like that, that does not utilize a raw fuel to produce heat, light, power, refrigeration type energy or heat transfer. Okay? All right. I'm glad we're looking at this. I'm excited. How about you? It's enlightening, isn't it? You don't have to spend a whole lot of time going through this code if I explain it thoroughly the first time. So then when we reference it today, it's not, you know, brand new. Okay? So again, I'm just going to kind of just continue down. And the very last thing I guess I'm going to end with here, the last couple of items. Number one, I showed you where the venting was. We'll visit that later. But look at here. I'm in chapter 24, and look what I find. I find something on clothes dryers here, ladies and gentlemen. Oh, my. I found that in chapter 15. Do you remember that? I believe it was 1504 to be exact. That was for electric clothes dryer exhaust systems. This one right here, I've got 2 chapters on clothes dryers. Let me show you the way. How about that? When I look at the first section right here, 2438, that gives me the listing and labeling and the testing and all that good stuff for gas-fired clothes dryers, okay? Gas, natural gas or propane. And then it says, hey, based on that, you're going to construct the clothes dryer exhaust system based on G2439 for gas fuel-fired clothes dryers. You will not go back to chapter 15 because that's for electric clothes dryers. Does that make sense?
Jerry,
All right. Jerry sounds like a broken record, doesn't he? But I'm telling you, if I drill it in now, there's no questions later. Okay?
Jerry,
Are we
Jerry.
good? Yes.
Jerry,
Go ahead, Fran.
question.
Yeah.
What is the means after the G2439.1? What is the reference to the parenthesis 614.1?
Oh, I'm sorry. Yes. Good question, Frank, right?
Uh-huh.
This right here, this is your code section for the International Fuel Gas Code, the Commercial Fuel Gas Code. Okay?
It makes sense. Okay.
So
I
yes,
couldn't
as
find
you,
it on mechanical. I couldn't find it on the IRC mechanical. So yeah, that was even the
Yeah.
mechanical book.
this is for the International Fuel Gas Code. This is for the Commercial Fuel Gas Code. So as you can see, a lot of this stuff, ladies and gentlemen, is in the Commercial Fuel Gas Code. So if you learn residential, I'll tell you what, you're not that far off from learning the commercial. Commercial deals with some bigger stuff and other types of appliances and equipment, but for the most part, it's pretty much the same. I would have to say maybe like 70% is the same versus commercial. Yeah, good question. Beautiful. So now you understand where the clothes dryer exhaust sections are, right? Look at this. I mean, these are specific appliances here. Look at this. I mean, I come down here and I have unit heaters. I have cooking appliances, gas cooking appliances. I've got gas boilers here. Hey, let's click on boilers since we are going to talk about boilers today. Look at this. Take a good look at this, right? Here's boilers right here. Now they give me the listing, right? The testing, the reference standards, things of that nature for gas boilers. Here's the installation right here. Take a look at this here, right? They got to be installed with the manufacturer's instructions, et cetera, et cetera, et cetera. Clearance to combustibles, but they don't tell you where to go look for the safety controls in the expansion tanks. That's chapter 20. Remember? Chapter 20 is where I get all that boiler installation stuff for safety controls and expansion tanks. Okay? It's all about navigation, knowing where to go look. All right, so I think that's going to wrap up my little, I don't know, dissertation of the table of contents. How's that? Let's get into it, right? All right, sounds good. Let me get that that workbook. All right, so here's your workbook. If you open up your page, your workbook to here's the contents. Let me just go over this real quick. Module 1, I'm going to start out basic, ladies and gentlemen. I'm going to go and show you like simple pictures, simple trim that you're going to find on boilers and furnaces and water heaters. We're going to go over that very simply, and we're going to get into more complex things as the day goes on. So we'll talk about the rough-in inspections for mechanical equipment, access, things of that nature. Module 2 right here, I'll just kind of highlight it as I go along. Module 2, we'll start to talk about fuel gas piping, fuel gas systems, some of the terms, things of that nature. More than likely we'll be in chapter 24. I have plenty of examples for you to understand fuel gas piping. Module 3, we'll talk about the rough-in inspection of venting of mechanical appliances. That's probably going to be a little bit later. We will go into module 4, which is rough inspection of air ducts, different types of air ducts. I'll explain metal ducts, plastic ducts, exhaust systems, things of that nature. Okay, and that's going to be our last section that we deal with. So we only have 4 modules to talk about today. Pretty simple. So as we kind of progress, let me get to the very first part. I don't think I have to go through the overview because I just went through that. Explanation of icons we did yesterday, things of that nature. Let's get right into it. How about this? We have a nice flow chart right here. And the residential mechanical process. I've got some really good stuff for you here today. And you can follow along in the workbook while I navigate through this PowerPoint presentation. Okay. All right. So here it is. We're going to define some basic terms. We're going to describe the mechanical system. We're going to describe the inspection process, what you need to do. And believe me, I'm going to throw in some stuff for plan reviewers as well, and for code officials, right? All residential stuff. And just like our plumbing workbook, at the end of each section or module, we will have checklists that will enable you to do a better job. Our checklists are designed for inspectors. You can even use them for plan review if you'd like. And the code sections are integrated in each line item. All right, let me get rid of this stuff. We already went through that. Here's where we're going to start right here. We're going to start right here, right in chapter 12. Remember chapter 12, that's where everything starts. It tells us, hey, code user, guess what? You're going to run from chapter 12 to chapter 13 all the way through chapter 24. This covers all mechanical systems, all mechanical administration, everything about mechanical and fuel gas systems and appliances and equipment you can find in those chapters, okay? We're going to cover rough inspections, mechanical, fuel gas, venting, and air ducts. And then we'll talk a little bit about final inspection. All right, here we go. Consequences of no inspection. Isn't that a beautiful house? Look at that. Nice little house. It looks so innocent, doesn't it? Well, this was a house in my jurisdiction when I was the building official several years ago. And let me tell you the story, what happened. It was February. I never forgot this. It was February. It was snowing. We had 2 feet of snow on the ground, and a gentleman came in the building department. He was a young guy in his 30s, right? Comes into the building department, slaps a whole roll of drawings down. The guy looked professional, had a suit and tie on. One of the permit techs said, hey, can you come up here and help him? He's got a couple of questions. So I went up to the counter and I met the guy. Nice guy. He says, I've got a brand new house. And what I want to do is I want to put an addition on. This attached garage didn't exist. The front porch roof did not exist. The deck did not exist. Okay. He was submitting plans for an attached garage. He was moving the electrical service from the house to the front of the garage. He was submitting for a new shed roof and a new front deck with stairs. That was the submittal, ladies and gentlemen. We took the plans in, we did the plan review. About a week later, he came back, picked up his permit for everything, electrical, mechanical, structural. We did everything at the county. So he picked up his permit and away he went, right? With his approved construction documents that we approved. Nice set of construction documents, showed everything. All the electrical. There was no mechanical, of course, but let me show you what happened. So this was in February. We had a pretty good sized county. We built, there was actually 600 houses built every year in our county. I don't know, plus a whole bunch of commercial and industrial jobs. So we couldn't really police anything. So by August of that year, I get a call. I'm in the office. One of the fire officials in our county called me up and he says, Jerry, I got to meet you out on a job. I said, for what? He said, we got a problem on this job. He says, I talked to the homeowner. He says, you guys approved the plans. I said, what's the address? Gave me the address. And sure enough, I got up on the computer and I find that there was never, ever any inspections on this project for the attached garage, the shed roof, and the deck, right? I said, Chief, what the heck is going on? He says, why don't you just meet me there? I said, okay, no problem. So I hop in my county car. I go out there and I take a picture of this. I couldn't believe it. And then we got up closer. I went to knock on the guy's front door. Look at that. Isn't that a nice bench there? Beautiful bench. You see something underneath that bench? I don't know. What do you think's underneath the bench?
Landing.
A jack in the box or something? I don't know. What, we're going to get a surprise when we open it up?
Crawl space
Like a
access.
crawl space.
Yeah,
Hey, Don, what do you think about that, huh?
that's great. That's good
It's a
stuff.
beautiful thing, you know? So
Where's the
you know
vent?
why the fire chief called me? Because the utility, the gas utility called him up. Now, we don't regulate,
I
the code
applied
does not
for a
regulate,
air permit not
the
too long
code
ago.
does not regulate,
And this
ladies and gentlemen, anything. This is called the point of delivery. It's at the outlet of the meter. We do not regulate the meter, the service regulator, the service valve, and all the pipe that supplies this. This is not our jurisdiction. But the fire chief called me because the gas company was going to shut this guy's gas off. And the owner said, well, the building department approved all this stuff, but yeah, he never called for any inspections and he never showed this on his construction documents, right? That was the kicker, right? So I'm out there, I take these pictures and I go back to the building department and I tried to call the guy, called the guy the next day. The guy wouldn't return my calls, right? So what did I have to do? Well, what you don't know and what you don't see here is I found out from the fuel gas company, the utility, they had their legal department involved in this already. This was a high pressure main. This was over 100 pounds per square inch coming into this regulator. You understand? That's called high pressure gas. It's reduced at the regulator. I think this was like a 2 PSI system, a medium pressure system. And this was a high pressure system. If there was ever an emergency on that street, this is kind of like your main shutoff valve. How can a service technician from the gas company, number one, know where the meter is and know where the utility shutoff is at the house? You wouldn't, because it's concealed now, right? So the utility company had a beef, and I understand it. So what did I do? The guy wasn't calling me back, the homeowner. So I had to issue a what? Number one, I issued a stop work order immediately. Stop work order, because the guy never called for any inspections that he received his permit for. And basically I got out there, everything was built. Everything was built. He put his new attached garage on. He took his electrical service off the house here, put it on the garage, but you don't see it here. He actually installed a new concrete slab, everything, no inspections. So I ask you, my esteemed colleagues in class today, are there consequences of no inspections? Could there be something that may be concealed, that may be an unsafe condition? Why do we do what we do, ladies and gentlemen? Think about it, right? We're like the gatekeepers sometimes. So how did this get resolved? Guy finally comes into the building department. He says, hey, Jerry, I'm real sorry. What do I have to do to make it right? I says, well, you know what? We're going to come out there. And I says, if you've drywalled inside your attached garage, which I know he did because I peeked in the window here when I was there. I says, you're going to have to remove some drywall so we can inspect the electrical, the structure, and whatever else was on the approved plans. And he had some aluminum soffit material up here. We made him take that down so we can inspect the structure. By the end of the day, he ended up spending probably a couple $1,000s more than he assumed that he would have to spend. Because I'll tell you right now, me nor any of my people, inspectors, would sign off on anything that's been concealed. I would never, ever do that. So you'll have to prove it to me. We worked with the guy, take a couple of pieces of drywall down, looking at the insulation, the wiring, stuff like that. You put them through their paces a little bit. You know what I'm talking about? To feel comfortable by signing your name on the dotted line, right? I've been to court before. You ever been to court? You got a subpoena? Make sure you're right, ladies and gentlemen. So that's what it's all about. Guess what the guy did for a living? He claimed, well, he didn't know he needed any inspection.
Building inspector.
Jamie, do you know what this guy did for a living?
Is he the mayor?
Police officer.
This guy, he claimed the guy claimed, he was a young guy. He was a hot shot though, he was like a city slicker, comes in with his suit and tie. I found out he worked for one of the largest commercial contractors in the United States. He was a project manager. He was a project manager for a huge commercial contractor. And I'm not going to name names, but I kind of laughed at him and he kind of snickered and he says, well, you know what? I figured I'd get my guys over there when I could. And I said, well, you know what? We'll work with you, but you got to prove to us that everything is compliant, So that was the moral of the story. That's called consequences of no inspection. So let's move on.
Jerry, hey, hold on one second, Jerry. I got a question on you there. This is Rhett from Baton Rouge. How did he get electricity turned on when he moved his meter without a final inspection approval?
Yeah, I knew you were going to ask that, Mr. Boudreau. You see this? What you don't see up here is he had split bolt connectors on there, Mr. Boudreau. He actually took this whole thing down, cut the irreversible connectors off of the house for the mast, right? He put his own insulator up here.
Ow.
Came down and put 3 split bolts on that Edison-based system. Or he had his electrician do it. That's what happened. So yeah, he had to get the power company out so they could come out, inspect it, and then seal the meter. That's what happened. Well, yeah, eventually, good question. Yeah, eventually what they did was, you see this picture here? The gas meter was right at this location underneath the bench. They had to come out and run a brand new gas line. They put it way over on the side over here, exposed on the side of the house. So you had to run gas piping from that point in through the crawl space underneath the house to refeed where it connected by the deck. Oh, he had to pay dearly for that. Absolutely. Yeah.
Oh,
And
my
that's the
gosh.
moral of the story.
But he didn't know he needed inspections.
Yeah, and that was the deal, So I'm sure you've dealt with some of those people out there. I mean, we've all been around for a while. You've heard all the tales, but we have to remain neutral and professional out there, don't we? Right? But don't sign off on something that you're not comfortable with, especially if it's concealed, I mean, you never know what's behind the curtain, So Tell them to take the curtain down a little bit, you know? All right, here we go. You ready? Let's get into this thing here. We're going to talk about mechanical stuff. I'm going to start out real simple. So, I mean, if you know this stuff, just stick with me. Believe me, I will definitely get more complex. I'll challenge you all day long. And maybe you'll challenge me too. All right? Hey, remember this term here? This definition is in the mechanical part of the code. You may find this in chapter 2, okay? Equipment, as it relates to mechanical means, it's all piping, ducts, vents, control devices, other than appliances. You see that italicized word there? That's your heads up. Anytime you read any of these I codes, you see an italicized word, you're going to find a definition in chapter 2. So we know what an appliance is, right? Something that utilizes energy, kind of like this thing here. It's a furnace. That's an appliance. The piping, the ductwork, the hangers, the controls, things of that nature, that is equipment accordingly. All right, I'm going to get this out of the way early. Do you remember I was kind of going off on a tangent this morning about fuel gas appliances when I said that's an 80% furnace or a 90+ furnace? That's a bunch of hooey. You know what? That is really not hooey. That's the energy efficiency of those gas fuel-fired appliances. However, the code does not speak in terms of efficiency at all. It categorizes the appliances. Here's your definition right here. Look at this. Vented appliance categories. You need to know this. Category 1 and Category 4 are the most typical appliances that we deal with on a daily basis when it comes to natural gas and propane appliances. Let me explain, okay? A Category 1 appliance. Well, let's read the definition, then I'll expound on it. It's an appliance that operates with a non-positive vent static pressure, okay? And with a vent gas temperature that avoids excessive condensate production in the vent. So if I come down here and I show you this picture right here, although this has a fan on it, it's not positively pressurizing this particular connector here. All right, it's just aiding in drawing in a little bit for inducing combustion through the burner assembly. That's all, just a little bit of airflow to help it draft properly. That's how it's designed. This is approximately about an 80% furnace, 80% efficient furnace. We vent these with metal ducts, metal vents, like single wall metal or double wall B vent, type B vent connectors. It's like a double wall. I'll show you what this is. But the flue gas temperatures in these appliances range anywhere from 250 degrees to about 450 degrees Fahrenheit. Now that's pretty hot, isn't it? If I went up to that metal pipe and touched that metal pipe, that would be pretty hot, wouldn't it? 250, 300 degrees Fahrenheit? Absolutely. Think about it. Think about it. The hotter the flue gases, the faster that they're going to travel up the pipe and completely get out of the building if it's piped properly, right? Because sometimes these Category 1 appliances are draft hood appliances, like water heaters with a draft hood on it. There's no fan assist on that, right? It's called naturally vented by gravity, right? Hot flue gases are going to cause a buoyancy, right? The hotter the flue gases, the more buoyant they'll become in a properly sized connector and a vent. And man, that'll draft really nice all the way out of the building. Remember, Category 1, hot flue temperature. Category 4, on the other hand, is a little bit different. Wait a minute, it's a lot different. This is an appliance that operates with a positive vent static pressure. I need to have a pretty strong fan to kind of blow this saturated vapor from the appliance to the outdoors, because I lower the temperature of the flue gas so much that it becomes so efficient and cost effective to operate. This is what we call the proverbial 90 plus furnace, 90 plus boiler. These things have efficiency ratings up to like 96, 97%, maybe even 98. What happens is you bring your gas in. Take a look at this section view here. You bring your gas into the main burner. You have two heat exchangers, ladies and gentlemen. Your primary heat exchanger right here. What's happening is your blower compartment actually circulates air over two heat exchangers, right? Primary heat exchanger comes here. As my burner operates, right, it goes down through a tube or a pipe. And as the air flows over that, we get heat transfer, right? It's cooling the flue gas temperatures down, and then it goes into a secondary heat exchanger that even cools the gas temperature down further with respect to the products of combustion. So by the time it ends up on the outlet of the secondary heat exchanger, guess what temperature it is? What kind of temperature do you think this is? And I can vent it with PVC pipe. What temperature do you think this is? Something. Take a wild guess. Little higher, Chris, little higher.
Atmospheric.
80.
Yeah, it's about 120 degrees, 125 degrees, you know, something like that. Saturated vapor running through this pipe. The products of combustion, ladies and gentlemen, for natural gas and propane, you know what it is? Don't say carbon monoxide. That's incomplete combustion. Proper combustion, when I have the right air to fuel ratio and everything is working properly, my gas pressure is set right, the two main byproducts are the following: carbon dioxide and water vapor. Carbon dioxide and water vapor. That's all you're getting through this with proper combustion. Carbon monoxide is called incomplete combustion. That's where I don't have the right air. Maybe I got too rich of gas. Something's happening. I'm getting incomplete combustion. That's when you start to derive carbon monoxide. All right, keep that in mind. This is a high efficiency thing. We categorize this as category 4. Now these other two right here, they come up. Category 3 will come up periodically if you have garage heaters. In fact, maybe I'll show you something a little bit later where you have to use a stainless steel venting method. Say it's a category 1 type of a garage heater, you know, those little heaters you put in your garage. They're classified as category 1, and you go up vertically through the roof. If you sidewall vent these things, in a lot of cases, the manufacturer is going to say, now you are categorized as a category 3 appliance. That means when I go out the sidewall, you may have a little condensate. You need to use a stainless steel venting system, okay? Now you understand the categories of appliances, all right? Why did I do this now? Because we're going to need it later. I'm glad I got this out of the way now because it's part of the definitions here. We will visit this when we design connectors and vents a little bit later on in the class. So remember this, okay? It's in your book as a definition. All right, let's kind of look at this stuff. Access. Here's your code sections right here for access to appliances. I'm going to start in chapter 13, okay? We're going to talk about, you know, some of the appliances. We'll talk about where appliances are permitted and how to access these things. All right, here's a typical picture right here. This is a boiler, ladies and gentlemen. This is a hot water boiler. If you take a look at this particular picture, look at what's happening here. This happens to be a gas-fired boiler. I've got a gas line here. I've got a pressure temperature gauge that's equipped on the boiler here. I've got a drain to drain the system down, but look what's happening here. When I take in my hot water here, maybe from baseboard or radiant heat somewhere in the house or under the slab, it's returned to the pump. The pump actually circulates the water through the boiler here. Maybe it's a cast iron sectional boiler. Maybe it's a water tube boiler. They make a couple of different types for residential. And it circulates through this heat exchanger here. heats up the water by means of gas, right? And then it pumps through in the supply line to go and supply baseboard heating, radiant tube heaters. Maybe you have coils mounted in your ducts, hot water heating coils, things of that nature. We have a gas vent here, or we should call it a connector. A connector is the pipe that connects the appliance to the vertical vent that goes out of the building. All right. Now, when we heat up water, what happens? When we heat up water, what happens?
It expands.
It expands. What else does it do when we heat up water? Increases
Pressure.
Pressure.
yeah, the pressure and the temperature, right? The temperature, right? Don't forget that, right? But we have to deal with the expansion, so we need an expansion tank here, all right? There are methods to size the expansion tank. I don't think we're going to go over that. It's pretty simple stuff, but manufacturers have good sizing methods as well as our code. So what this is just a tank here. Half the tank is filled with air, half the tank is filled with water. So as I heat up the water, I have a volume expansion. It actually takes up the volume in the tank here, right? By this air bladder, if you will, in the top of the tank. It gives me a cushion to take up the expanding water when I heat it up. If I did not have this expansion tank, ladies and gentlemen, guess what would happen? This safety valve would go off every single time. We couldn't deal with the pressure increase if we didn't have the expansion tank. We use it as a cushion. Take a look at this appliance here. Now, I'm going to ask you a question here. I see this little appliance. It's like a little room heater. It's just got a gas line. It's got a heat exchanger, and it's got maybe the pipe and pipe type system here, where this is my outlet for the exhaust products of combustion, and it probably takes in air for combustion through a double pipe system. That's here to there. But how does it heat the room? There's no fan on here. How do you think it heats the room without a fan? There's no fan on here.
It's got to be by convection.
Don?
Convection?
Excellent. Excellent, Don. Fantastic. Yeah. Convective air currents, right? I've got a, we'll call it a, how do we call it in engineering? It's a warm body or a heat source, right? What happens is, this is a true statement, hot air rises, right? Heat does not rise. Make no mistake about it. Hot air rises, right? From this heated body. Hot air is going to rise. Cold air is going to drop. In turn, we have these convective air currents that form in small rooms, right? We will get that convective air current flowing across this hot body or this hot device here to circulate within the room. Now, here's where we have a forced air furnace. This is an upflow type furnace here. I've got a plenum on the top here. This compartment down here is your blower compartment, where I've got a squirrel cage type motor, blows up across over the heat exchanger into the supply air, and we'll have trunk lines and runouts, things of that nature. We will return the air through a return air drop. This is called a return air drop. Enter the furnace. There should be like a filter rack over here, cleaning the air, of course, before it goes back into the blower and continues to recirculate through the house and returns it back. So it's a more dynamic system, isn't it, with a fan motor. Now, wait a minute. This is a mechanical class. Why the heck am I showing you a water heater? Can we use a water heater as a heating source for heating a house?
Sure. Yep.
Yeah,
Yeah.
right. Like I maybe can feed some fin tube, maybe a radiant tubing system under a slab, put a pump on this thing. But if I do that, this water heater has to be listed for both. If I wanted to use it for plumbing, potable water, and heating, it's got to be listed and labeled for suitability for both applications, okay? So take a look at this. We have a pressure temperature relief valve here. Here's my hot water port. Here's my cold water coming in. And by the plumbing code, you remember from yesterday, I need one valve, don't I? One valve at that point. When we do the hydronic system, then we're into another chapter in the mechanical code for the hydronic piping. All right, moving on. Where do we find these mechanical appliances? Well, you find them in utility rooms, basements, closets. Wait a minute. We're allowed to install mechanical appliances in garages? Is that a true statement?
Yeah.
Well, my car's got gas in it. What if the gas leaks in the garage? Won't my garage blow up? How come we don't have garages blowing up all over the place? Carla, you're laughing. Help me, Carla. Tell me why. What do we do special for appliances in garages?
You have to
First of all,
elevate 'em.
elevate them.
Yeah, we got to
Double
elevate them.
gas.
There's something in
Those
the
up- Vapors can't get to the ignition source, at least we try. Plus the garage is very large. It would take an extraordinary amount of gasoline to increase the vapor.
Yeah,
condensation.
the vapor tends to hover around the finished floor, and we have to elevate our appliances above the any ignition sources, and we'll find out where that's at, of course, coming up soon. So let me show you where we're going to start here. This is where we start. If you have an appliance in a room, right, call it a mechanical room, whatever, it's going to give you some minimum requirements here, right? I needed an opening or a door. I don't have to have a door, ladies and gentlemen. I've seen code officials say, you need a door on that mechanical room. That's incorrect. It's an opening or a door. It can be wide open. It doesn't matter. It's got to be at least 24 inches or wide enough to allow the removal of the largest appliance. If it's wider, my furnace or my boiler, if it's wider than 24 inches, then guess what? That drives the opening or the door accordingly. We need service space, ladies and gentlemen. We need a 30 by 30 space here. We need at least, right here, a service space not less than 30 inches deep, right? That's measuring perpendicular to the service side back and the height of the appliance. So in other words, how high the appliance is as well. And then not less than 30 inches at the front or the service side of the appliance. So we're talking width, side to side, right? Depth, and then height of the appliance. Three-dimensional. Three-dimensional. That's for a room. How about an attic? What do you think? Can I put things up in an attic like a furnace?
Yes.
Probably. Right, Doug?
Mm-hmm.
But there's some criteria here that you got to follow. You got to design this platform right here as a floor. Did you know that? It references chapter 5 in your code book right here. You have to design this as a floor if and only if you are away from this attic access. Let's start here. Well, what type of opening do I need for the attic access? You can find that in this code section right here, 1305.12. Go to the very last sentence right here. See this? It says the clear access opening dimension shall not be less than 20 inches by 30 inches, right? And large enough to allow removal of the largest appliance. Sometimes, maybe they'll put the furnace in, prior to doing any kind of, maybe at the same time they're running the ceiling joist, right? So you got to make sure that you can get this furnace, this air handler, whatever it is, out of that scuttle hole or that attic access, or it's got to be larger than that if in fact the equipment and or the appliance is larger than this opening. I don't know, as a plans examiner, I'm always looking for this. Even when I review residential plans periodically, I'm always looking for the attic access when I have mechanical appliances in the attic. You have a distance of 20 feet, ladies and gentlemen, 20 feet to get to the appliance, right? And you have to have your working clearances at the appliance. Remember the 30 inches by 30 inches by the height of the appliance? That's what you need over here. So your floor is going to be flared out a little bit to provide access to the service personnel. I don't know. Let me ask you a question. Has anybody ever been up in an attic to service or even look up in an attic? You ever walk up in an attic before?
Oh, yeah.
Yeah.
Right, right. Well, you know what? Years ago, I sound like an old man, but I'm really not that old, you know? We used to do service, right? I worked for a big commercial company, but I did a lot of side work when I was a young guy. And I used to install these things, right? So we installed a couple of air handlers up in an attic one time, right? So I'm tiptoeing across the ceiling joist because back then we didn't have these regulations, you know, with a floor being built and lights and receptacles. I'm tiptoeing across the ceiling joist and my foot went right through the drywall. I was in some lady's house. My leg was hanging down in her living room. Can you believe that? Crazy stuff, you know? Well, I had to fix her ceiling anyway, but anyway, it's a lot safer now, ladies and gentlemen, with these requirements. So here it is. Did you know that there's an electrical requirement here? There's actually two that you need to know about. You need what's called a luminaire, a fancy French lighting fixture, right? A luminaire. That's a lighting assembly, by the way, located near the appliance. You also need a receptacle near the appliance. Look at this right here. See? I need a luminaire controlled by a switch located at the required passageway opening. Okay, here's my switch. That could be a good location. Turn that on. The luminaire illuminates so I can see what I'm doing up in the attic space. Also, you need a receptacle. Where is that? And a receptacle outlet shall be installed at or near the appliance. Now, how far away is at or near the appliance for the receptacle? Does anybody know? At or near? You guys took the electrical course 2 days ago with that electrical guy, didn't you? Do you
The
remember?
inspector?
How far away from the appliance do I have to have that receptacle? Jerry's having fun on Friday. Yeah.
25.
25. Who said 25? 25. It's like a bingo game. Anybody got 25? Frank.
25 is usually for the air condition equipment, so for the condenser, that's probably why it's required that too.
25 feet.
As per the inspector.
No, don't say that. It's in the code. You go to chapter 39 here, it's somewhere in there, but if you use the National Electrical Code, it's in 210.63. 210.63, and we'll find it in chapter 39 as well. I need to be within 25 feet of that appliance for my receptacle for the heating and air conditioning appliances, okay? That's why it's referencing chapter 39. That's your electrical chapter for that provision. All right, cool. So that's the attic. Let's go underground. What do you think? Let's go underground. How about a crawl space? Yeah, we can have air handlers and furnaces and crawl spaces. But the key to this here is, oh, let me go back. There was an exception I got to show you. The exception number 2 to the attic here, I can be 50 feet away from the access to the appliance if I have enough headroom, ladies and gentlemen. Look at exception number 2. If the passageway is, of course, unobstructed, which it should be, this floor here, right? And not less than 6 feet high, right? In other words, I measure from the platform here, 6 feet to any kind of structural member, like a rafter or a truss, right? And if I have that headroom, like 6 feet or more, I can be 50 feet away from this access opening. That's pretty good, I think, right? You know, those attic trusses that we use once in a while in residential construction, gives me enough headroom, or maybe a steep pitch rafter. If we go underground, right? Same thing here. I need some kind of an access here. This happens to be a floor access right here. And as you can see, removable of the largest appliance, et cetera, 30 by 22. But here, when I come down here, I'm on solid ground. I'm not tiptoeing, or I'm not bound to a floor system on top of ceiling joist, right? I'm on solid ground, maybe earth or a scratch coat of concrete, right? In this case, if my headroom is, right, not less than 6 feet by exception number 2, then I can have an unlimited distance in a crawl space to get to my air handler, to get to my horizontal furnace. That's enlightening. It's unlimited because the floor is solid all the way around. I'm not worried about falling off that platform like an attic and going through the drywall ceiling, right? All right.
Jerry?
Yes.
Yeah, just a quick tip out here in Washington State, what we find, well, we're putting gravel in the crawl spaces and visqueen over the top of it.
Right.
And of course, that's tough on the knees. So, we ask for a solid flooring, and also in the attic, we ask that the flooring be nailed or fastened somehow so it doesn't move around. And we, in existing buildings, we constantly find moving around stuff. And so, it's very difficult to not go through the ceiling, like you said.
Yeah, that's a great comment, Don. I agree with you wholeheartedly. But one good thing of consolation, given our newer codes here, is now you're driven right here. See this?
Yeah.
It needs to have a continuous solid flooring in the attic in accordance with chapter 5. So that means you got to nail it down accordingly, like a floor.
Yeah. Yeah, what we find though is double 2x6s thrown up there, and have a good luck until the final, and of course by that time they're buried with 38 inches of insulation. So anyway, just stuff to look for.
Yeah, good point. It's like walking the plank up in the attic space, right?
Indeed.
Right. You have I hope you have a picture of this in your book. If you don't worry about it. I know you have a picture of a nameplate. So let's look at this. This is called label information. Here's your code section, M1303.1. M1303.1, permanent factory applied nameplate. So in other words, it's got to contain some information, not only for the mechanical inspector, but for the installer. So if I look at this label here, look at this label real close. Kind of get your face right up to the screen there. I don't know if you could see this, but I'll dictate, I guess. It gives me what's called category 1 forced air furnace. Do you see that up at the top? Category 1 forced air furnace. Can you see that? Yeah? All right, we good? All right, what's a category 1 appliance? You remember? What is a category 1 appliance?
No blower, just gravity rising.
Well, it could have an inducer motor on it. That's fine, like the fan assisted. But what are the flue temperatures hot or?
It heats the flue temperatures.
Flue temperatures, right? Anywhere from 250 to 450 degrees Fahrenheit. Category 1. So we're assured now that we understand what this is. I'm looking for some kind of metal venting thing here. I like that. The first line, I learned something about the appliance. Fantastic. Look at this. How about the second line? I'm given an electrical information. It says electric 115 volts, 60 hertz, that's cycles per second, single phase. And then it's telling me my maximum total input ampere rating is 8.51. So this allows the electrician to size the circuit conductors, the branch circuit conductors, and the overcurrent protection device like a fuse or a breaker for this furnace. And it gives me the voltage, 115 volt all day long. Now, when we get down here, do you see this area right here? It says hourly input rating. When we start to talk about gas piping, ladies and gentlemen, we are concerned with the input rating of the appliances, okay? The input rating of the appliance is rated in BTUs per hour. BTUs per hour, British thermal units per hour. Do we know what a British thermal unit is?
It's a measure of heat.
80,000.
It's a unit of measure for energy, okay? And if you think about it in theory, it's the amount of energy it takes to raise 1 pound of water 1 degree Fahrenheit, okay? No matter what energy source it is, the amount of energy it takes to raise 1 pound of water 1 degree Fahrenheit. Pretty simple, right? However, when we talk about input rating, we're talking about energy per unit time. Always say BTUs per hour, okay? That's the energy rating. This furnace, category 1, is an 80,000 BTU per hour input rating. Does that help me? Yeah, it gives me the capacity of the furnace. Also, right next to it, look at this here. It says manifold pressure. The manifold, this is a manifold right here. You see this right here? There's a pipe that runs across here with nozzles in it. That's a manifold. It's called a gas manifold. The manifold at that point from the manufacturer, we need 3.5 inches water column of gas pressure. All right. I'm going to bring everybody in now because I need to go through this. Believe me, I'm going through a lot of stuff here that's going to benefit us in the afternoon. Do you know what water column pressure is, ladies and gentlemen? You ever hear of that? Water column? What is water column pressure? Anybody?
Something plumbers talk about.
Something plumbers talk. Yeah, excellent, Doug. Something plumbers talk about. Let's
Isn't
get
it the
into it
pressure of
deeper. Anything
stacking?
else?
Isn't it the pressure of, I'm trying to go back to my military days.
Yeah.
The pressure of like just water applied to water in like a static state.
Yeah, and then if I put, yeah, Jason, you're on the right track. Let me put it to you this way. If I want to measure a low pressure, right? Now, if I said I could put a gauge on a pipe, I don't care what kind of pipe it is, and I can measure a pressure, I'll put a gauge on a pipe and I measure 20 PSI, 20 pounds per square inch. I say to myself, well, that's a pretty good pressure. But what do I do if I have a real low pressure system and I put that same gauge on my pipe and I'm measuring like a fraction or a decimal? I don't want to deal with fractions. I don't want to deal with decimals for real low pressure, like a 1/2 pound of pressure, a 1/4 pound of pressure. I want to work with whole numbers, okay? I don't want to deal with decimals or fractions, do you? That complicates things for me. I don't like it. Plumbers don't like it. Hey, Doug, you said that's what plumbers use, right? Well, plumbers don't like them fractions or decimals, so we shouldn't either. Can I show you something? Part of the class here? I give you guys extra because I like you. How's that? Isn't that good? Take a look at this. Can you see this on your screen? Can you see this on your screen? Give me a thumbs up. Anybody? Anybody?
Yep,
Thank
it's there.
Yeah.
It's there.
Thank you. All right. Jason, from your military days, you're exactly right. This is called a YouTube manometer. You see this thing here? I could go up to Home Depot or Lowe's and buy some plastic tubing. I don't care what it is. Buy plastic tubing, whatever it is. Doesn't matter the size. And I'll form it in the shape of a U. You ready? And I'm going to fill it up with water. Once I fill it up with water, guess what? It's going to seek its own elevation because atmospheric pressure is pushing down on both ends of the plastic tube. Is that clear? Does that make sense? We say the fluid is in equilibrium. It seeks its own level and it's equal on both sides of the tube, right? Try it yourself. Go up to Home Depot over the weekend, buy a tube, fill it with water, and you'll see that the water seeks the elevation exactly the same on each side of the tube. Why is that? Because atmospheric pressure is pressing down equally on both sides of the tube. Now, how do we measure a low pressure? We do this with duct systems, air distribution systems, fuel gas systems, things of that nature. When we induce pressure on one end of the tube, like this here, if I connected this up maybe to a low pressure gas pipe and the pressure comes down, what's it doing to the water? It's displacing the water, right, Harold? Yeah. Harold, what happened? It went from zero. Here's my zero mark. It actually displaced the water in the tube. How many inches?
2 at that point.
2.
2 inches. We started at 0. That's our baseline where the water was level, right? Like this. And if I induced a pressure here, what pressure was that? That's 2 inches water column. All right.
Right.
So this is how you measure pressure in low systems. I'm not done yet. Believe me. I'm going to make this relatable and understandable for you. Now, if I came up here and I said, well, gee, I want to know how much 1 PSI equates to inches water. If I applied a 1 pound pressure to this real long tube, I start out at 0, I don't know, somewhere down here, right?
Mm-hmm.
How high would it raise that water level up if I induced a 1 pound pressure on this side of the tube? Take a wild guess. How high would it raise the water in the tube?
2 inches.
1 inch. Just be 1 inch, wouldn't it?
It's a 2-to-1 ratio.
How many again?
14 inches.
All right.
It's
Cart,
2-to-1 ratio.
Five
For every
pounds
1
is
pound
14
of pressure,
inches.
you raise it 2 inches.
Everybody's doing a Google search now, right? No, unless you know, right? You should know this off the top of your head if you're mechanical or plumbing, right? But maybe you don't. That's okay. If you're just getting into it, you're going to know now. Here's how this works, right?
With
It's
that
going to be approximately, it's probably going to be approximately what?
15.7.
A lot, right? Like 28, right?
Yeah.
Here, I got a little calculator I developed here. So if I put 1 pound of pressure, right?
27.
1 pound of pressure, it's 27.7 inches. So call it 28 inches. 1 pound of pressure equates to 28 inches water column. Okay.
Or 7 inches for a quarter PSI.
Well, let's do this. How about a half a pound of pressure? If this is 28 inches for 1 PSI, what's a half a PSI?
14.
14 inches,
14.
right? All right. So if it's a
7 is
quarter
quarter.
PSI, what is it?
7.
7, right? So I go from 28 inches at 1 PSI. I'll prove it to you. Look, I have my little handy dandy calculator here, right? 1 PSI equates to 28 inches water column, right? I'm going to go to 14. I'm sorry, a half a PSI, right? Which is 0.5. That's a half PSI. That's about 14 inches. It would raise the water column, right? I'm going to go back up there and type in a quarter PSI, which is 0.25, right? 0.25. Boom. 7 inches water column. Isn't that amazing? So look at the ratio.
You know, Jerry?
Yeah.
Jerry, you know, this is the method that you use to level fences.
To level fences?
Yeah.
That's interesting. I never leveled a fence by inches of water column,
Yeah,
maybe in a
you buy
flood or
this
something.
clear. Well, you grab one of these. If you don't have a level, you know, you can actually go grab this at Home Depot.
Yeah, you're right. Yeah,
A clear plastic
with ya.
pipe, and put them on one end on whatever, let's say 5 feet,
Right.
and it has to give you another 5 feet where it's supposed to be.
Yeah. Yeah, very good.
One way to do it.
Man, I learned something new today. Thank you,
There you go.
Francisco. Yeah, right on. I'm going to start a new company. We're going to call it water level fences. Very
Well,
accurate anywhere. But anyway,
Without the
And this
tools,
only
of
applies
course,
to-
nowadays we use the levels, but it's one way,
yeah. So anyway, do we understand this? I put the equation here. Let me make this bigger in case you want to write this down. Here's the equation right here. This is simple. Here's my equation right here. I say water column equals the pressure applied in PSI. So in other words, you put the pressure and you divide it by the following. You put this in parentheses in the denominator. If you do this in your calculator, it's 62.4. You know what 62.4 is? It's the weight of 1 cubic foot of water. That's how much 1 cubic foot of water weighs. And then you divide that by 1728. You know what 1728 is, right? That's how many cubic inches are in a cubic foot. So your ultimate result is going to be in inches. This is going to be in inches when you solve the equation. Your only variable, ladies and gentlemen, is pounds of pressure. And there's your equation. It's pretty simple. So this is a method that we use, ladies and gentlemen, for measuring low pressure gas pressure in our systems. All right.
Does the size of the pipe matter?
Size of the pipe does not matter whatsoever. No, sir.
The only thing that would matter on this is only for water. Back from the military days, a different fluid with different viscosities, your formula would somewhat be the same, but depending on the fluid, your distance traveled would be different.
Exactly. This is for water. You're talking about specific gravity of different types of fluid like antifreeze, oils, things of that nature. You're right, Jason. If we had different fluids, they would have different specific gravities and different weights. They would weigh more or less than water. Very good. Excellent. Good point. But yeah, we're just talking about water here. It's that simple. We'll use water column measurement. All right, I'm ready for a break. How about you? We should get coffee, don't you think? We should get
Indeed.
coffee Friday. All right, I'll see you in 10 minutes, okay?
Jerry,
Yes.
is there a gauge or something that measures water column? What does that look like?
Yeah, there is. Yeah, you can buy a gauge, Doug, that has water column increments on it and a needle. Yeah, and some of them come with a hose, you know, and a barb and a like male thread on it where you can thread it onto a pipe.
So what
Yeah.
what sort of fuel gas application would you use that for instead of a regular, 5 psi pressure test gauge?
You would use it for most every fuel gas pressure analysis in residential because the bonnet or the manifold pressure regulated by manifold by manufacturer, you'll find that they cannot exceed 3.5 inches water column. So as an installer of furnaces and things of that nature, you need to measure the gas pressure at certain parts of your gas piping system. At the manifold, you don't want to have anything less than 3.5 inches water column. So you'll take the port off at the manifold, stick your manometer on there, your YouTube manometer or your gauge to measure that pressure. It's for low
Usually every time I've seen like a plumber do a pressure test or I've seen it inspected, they usually just put on like a 5 psi gauge and they'll crank it up to like 4 and leave it there for like an hour.
Oh, that's a pressure
4.
test. That's a pressure
Right.
test. That's not what we're talking here. This is for operational purposes, to measure the amount of pressure in inches of water for proper operation.
Okay.
Do you follow?
Not really. I mean, do you have like a diagram or something to show where on a system you would see this gauge and what it would be testing?
Sure. I'll bring that up because when we get into gas piping,
Okay.
I'll show you a gas piping system, and then ask me the question when I show you the diagram, okay? And I'll show you how that
Okay.
works. Okay.
Also,
All right, thanks.
Yeah.
I'm sorry, Jerry. I'm so sorry. Also, during the when she come back, could you show me how to work that formula? I'm trying to work it and I'm not getting the 28 inches. I don't
Oh,
know how
okay.
to apply the formula.
Yeah, sure. No problem. Here, I'll bring it up here. I'll leave it up here. See, what you're doing in your calculator is you put that in parentheses.
Okay.
You see the denominator here? You put your pressure in the numerator right here.
Mm-hmm.
It doesn't matter. You can just string it all out. Your calculator should do it. Just take your pressure, divide it by 62.4, and then divide it again by 1728. If your
Okay, so the
calculator doesn't do
pressure-
it that way, then put this in parentheses in the denominator.
So the pressure here was 1, right?
Yeah, just one.
Okay,
Yeah, just
okay,
one
all right.
divided by all this stuff.
Okay, I got you.
Try that trick. Let me know. I'm going to go get a cup of coffee. I'll be back in a few minutes, okay?
Okay.
And then I'll check your answer, okay?
Okay, thank you.
Okay, welcome back, everybody. Welcome back. Everybody's here.